Here we will learn how to find out the area of triangle in Cartesian plane. But if we say area of triangle, then normally it comes in our mind is half base into height. This is when we know the base and the corresponding height. Also, area of triangle can be found with the help of sides when sides are known to us. In this case, S is the semi-perimeter and this formula is famous by Heron's formula name. Okay. But here what we have got is 3 points are in the Cartesian system and we have to find out the area. It means that we know the coordinates of these 3 points. So point A coordinates are x1, y1, B is x2, y2 and C is x3, y3. We have to find out the area of this triangle ABC. For this we have done one construction. This from point A we have dropped a perpendicular AP on this x-axis and this BQ is perpendicular on x-axis, CR is perpendicular on x-axis. It means that this figure ABQP, these two lines are perpendiculars on the same line, so they will be parallel. It means this figure will be a trapezium. Since this QP, that is also perpendicular on these two lines, so this is the perpendicular height. Similarly, in this case, just see this figure APRC, that also is a trapezium because AP is perpendicular, CR is perpendicular, so these two lines are also parallel. So a quadrilateral whose one pair of opposite sides is parallel, only parallel, that figure will be a trapezium and the height of the trapezium will be PR. So just see that this trapezium plus this trapezium, if we get, the total area will be ACRQB. From there, if we subtract this part, this is what type of figure? This also is a trapezium. So trapezium 1 plus trapezium 2 minus this trapezium will give us the area of triangle ABC. So area of triangle is equal to area of trapezium ABQP plus APRC, means this one, and area of plus this one minus this trapezium. So first we will take ABQP. Now see, BQ and AP are two parallel lines. So the area of trapezium is half into sum of parallel sides into its height. So here it is y2 and this is y1. So we will substitute the values. BQ is y2 and AP is y1 as it is the perpendicular distance of this point from the x-axis. Now look at this QP. This QP is perpendicular distance from this y-axis. So QP will be equal to x1 minus x2. Till here it is x1 and minus this x2. Similarly, we will find out the area of another trapezium AP, that is y1. So half y1 plus CR is y3. Now look at this PR. PR will be total till here it is x3. Till here it is x1. So this PR will be x3 minus x1. Now the last trapezium, this one, that is BCRQ. So half of BQ. BQ is y2 plus CR is y3 and QR. This QR is till here it is x3, till here it is x2. So this QR will be x3 minus x2. Okay, so what we have written? The area of trapezium in terms of the coordinates of points A, B and C. Now we will find out the area of triangle ABC. That is, half we can take common from all three and open the brackets. Now here I am taking this absolute value of this whole expression. Since the area of triangle cannot be negative, and sometimes we can get the coordinates negative also. So overall the area will come negative, but by taking the absolute value it will become positive. So here open the brackets. y2 is multiplied here. y2 x1 minus y2 x2. Okay. Then plus y1 x1 minus y1 x2. Here it is plus y1 x3 minus y1 x1 plus y3 x3, and this into this will be y3 x1. Now here is minus sign. Okay. So we have to see the overall sign. y2 into x3 but minus. So minus y2 x3, this minus sign and this minus sign will be plus. So y2 into x2. Then after this y3 into x3 but minus sign. So y3 x3, and last is minus and minus. This will be plus y3 x2. So what we have seen? We have just opened the brackets, and if you observe, there is x1 y1 here and x1 y1 here with the opposite signs. So x1 y1 and x1 y1 will be cancelled. Similarly, this is x2 y2 and x2 y2. So x2 y2 and x2 y2 will be cancelled because opposite signs are there. Then we will search for x3 y3. This is x3 y3 and this is x3 y3. Both are opposite signs, so that is also cancelled. Remaining terms we will write. Now, if you look at the expression, there is x1. So first we will search for x1. Here it is x1 and here it is x1. So out of these two, we will take out x1 common. So area of triangle is half. Now x1 common from this term and this term. So what is left out? y2 minus y3. y2 minus y3. I have combined the terms and I have taken out the x1 common out of these two. Now search for x2. This is x2. Okay. And in this is x2. But this is positive and this is negative. So first we will write the positive term. So x2 is common. So y3 minus y1. So plus x2 and y3 minus y1. Plus we will search for x3. Now look over here. x3 is this and x3 is this. This is positive, this is negative. So from these two, x3 is common. So y1 minus y2 is left out. So what we have observed, with x1, it is y2 minus y3. With x2, it is y3 minus y1. With x3, it is y1 minus y2. If we will write it in the cyclic order also, then it will help us to write the formula for area of triangle when the coordinates are given. So this is the formula to find out the area of a triangle in the Cartesian plane when the coordinates are given to us. Now there are two conclusions. If we are getting the area as 0, it means that the points are collinear. Collinear means they lie on the same line. And if the points are collinear, and if we will apply this formula, we'll get the area of triangle as 0. There are three possibilities. The possibilities are, this point B can be on AC, or point C can come between A and B, or point A can come between B and C. We can check it by area of triangle as 0 to prove that the points are collinear, or we can also apply the distance formula to prove that the points are collinear. That will be AB plus BC will be equals to AC in this case, In this case, AC plus BC will be equal to AB, or in this case, AB plus AC will be equal to BC. So by applying the distance formula or by proving area of triangle 0, we can prove that the points are collinear. So this we have seen, area of triangle and the conditions for the points being collinear in the Cartesian system.